Hi guys, today you are watching the next physics video about work power energy. If this one is helpful to you, then you must subscribe the channel. If you have any doubt, write in your comment section. I will give the answer. First we discuss the mechanical energy and its defined form. Mechanical energy is the energy possessed by the object due to its rest or motion. That's mean mechanical energy is of two types. One is potential energy, which is due to its rest condition, and kinetic energy, which is due to its motion. Now potential energy is of two types. One is gravitational potential energy and given by mgh. Another form of potential energy is elastic potential energy. When a force is applied on a spring, then it is elongated by a distance x. Then potential energy stored in elastic in spring equal to half k x square, where k equal to force constant and x is the displacement from its mean position. This formula or of elastic potential energy is derived in class 11, and if you have any special interest in this energy, you must write in comment section. I will make another special video. Then we derive the derivation of kinetic energy. Consider a object of mass m moving with a velocity v in this direction, and a force is applied opposite that of motion of object. Then body will retard with a acceleration a. We know kinetic energy equal to amount of work done which the moving body can do before coming rest. That's mean before rest the amount of work equal to kinetic energy. Therefore kinetic energy equal to force into displacement. Now from the equation v square equal to u square minus 2as, we get s equal to v square by 2a. Now putting the value of s equal to v square by 2a in equation 2, we know f equal to ma, s equal to v square by 2a, therefore k equal to half mv square. That's mean kinetic energy equal to half into mass into velocity square. Now we discuss relationship between kinetic energy and momentum. We know kinetic energy equal to half mv square, momentum equal to p mv. Squaring 2, we get p square equal to m square v square. Now multiplying 1 by m, we get k into m equal to half into mv square into m, that is km equal to m square v square by 2. Therefore km equal to mv square means p square, the p square by 2. After cross multiply, we obtain p square equal to 2km. Therefore p equal to root under 2km or k equal to p square by 2m. You remember this relation, k equal to p square by 2m. Now we take an example. If a light body A of mass m and a heavy body B of mass m both have same momentum p, then ka equal to p square by 2m, kb equal to p square by 2 capital M. Therefore ka by kb equal to p square by 2m by p square by 2 capital M equal to capital M by small m. Now capital M is greater than small m, therefore m by m greater than 1, so you obtain ka by kb greater than 1. That is, light body A have greater kinetic energy than the heavier body B. Case 2, if a light body A of mass m and a heavier body capital B of mass m both have same kinetic energy, here we assume that both have same kinetic energy, therefore ka equal to pa square by 2m, kb equal to pb square by 2m. here Ka equal to Kb, therefore P a square by 2m equal to P b square by 2 capital M, therefore P a square by P b square equal to 2m by 2 capital M, therefore equal to small m by capital M, therefore P a by P b equal to root under m small m by capital M greater than small m, therefore this ratio less than 1, therefore Pa by Pb less than 1, that is Pb greater than Pa. That's mean heavier body have greater momentum compared to lighter body. Now we discuss work energy theorem. That's mean work equal to energy. According to work energy theorem, the work done by a force on a moving body in a given direction is equal to the increase in potential energy. That's mean change in kinetic energy equal to work done by any object when it is in motion. Let us consider an example: a body of mass m moving with the initial velocity e. When a constant force is applied on the body, its direction of motion, it produces an acceleration a and the velocity of the body changes u. We know F equal to ma and W equal to Fs. Here object is in increased velocity, that's why we apply v square equal to 2s and we obtain s equal to v square minus u square by 2a. Putting the value of s in equation 2, we get W equal to F into v square minus u square by 2a, and we know F equal to ma, and we obtain W equal to half mv square minus half mu square. That's mean W equal to final kinetic energy minus initial kinetic energy. That's mean increase in kinetic energy equal to work done. This is known as work energy theorem. That's mean change in kinetic energy or increase in kinetic energy become equal to the work done of any moving body. Now we discuss about kinetic energy. Kinetic energy is of three types: translational kinetic energy, rotational kinetic energy, vibrational kinetic energy. Translational kinetic energy means when object is in a straight line. Rotational, when an object rotates around a circle or in an axis. Vibrational means when object is in to and fro motion, then the kinetic energy known as vibrational kinetic energy. Example: a wire clamped at the both ends, when struck in the middle it vibrates. That time energy is known as vibrational kinetic energy. While in rotating wheel, energy known as rotational kinetic energy. For a freely falling body, kinetic energy known as translational kinetic energy. A rolling ball, in case of rolling ball or the wheel of a running vehicle, have both translational energy and rotational energy. Now we discuss conversion of potential energy into kinetic energy. Example 1: when an arrow is shot from a bow, it has kinetic energy. So when a string of bow is pulled, that's some work is done which is stored in the deformed state. That's mean in the form of elastic potential energy. যখন একটা বউকে টানা হয় তখন সেটা কি এনার্জি গেইন করলো? পোটেনশিয়াল এনার্জি। অন রিলিজিং দ্য স্ট্রিং টু শুট অ্যান অ্যারো, যখন তীরটা ছাড়া হলো, দ্যাট টাইম পোটেনশিয়াল এনার্জি চেঞ্জেস টু কাইনেটিক এনার্জি। তাহলে ফার্স্ট পোটেনশিয়াল এনার্জি স্টোর, দেন ইট ইজ চেঞ্জেস ইনটু কাইনেটিক এনার্জি। এইভাবে কোনো ধনুক থেকে তীর ছাড়া হয়। এ বল ইজ প্লেসড অন এ কম্প্রেস স্প্রিং, একটা বলকে স্প্রিংয়ের উপর ফেলা হলো। হোয়াট ফর্ম অফ এনার্জি ডাজ দ্য স্প্রিং পজেস? তাহলে ইনিশিয়ালি স্প্রিং পজেস ইলাস্টিক পোটেনশিয়াল এনার্জি ডিউ টু ইজ কম্প্রেস স্টেট। On releasing the spring, ball flies away. That's mean elastic potential energy is converted into kinetic energy due to which ball flies away. That's mean যখন বলটা স্প্রিংয়ের উপরে ফেলা হলো, স্প্রিংটা পোটেন্সিয়াল এনার্জি গেইন করলো এবং সেই স্প্রিংটা পোটেন্সিয়াল এনার্জিটা কাইনেটিক এনার্জি কনভার্ট হলো, সেই জন্য বলটা আবার বাইরের দিকে বেরিয়ে চলে গেল। Example 3, a wound of watch spring has the elastic potential energy. When it unwinds, the potential energy changes into kinetic energy due to which hands of watch move. That's mean potential energy is converted to kinetic energy and watch started move. Always remember, potential energy first changes to kinetic energy, then it is put of use. তার মানে পোটেনশিয়াল এনার্জি প্রথমে কাইনেটিক এনার্জি কনভার্ট হবে, তারপরে সেটা কাজ করে। এখানে ডিফাইন ফর্ম অফ এনার্জি ডিসকাশন করা হলো। সোলার এনার্জি obtained from sun, heat energy from heat, light energy is obtained from light, chemical energy, chemical compound, hydro energy from water, electrical energy from current, nuclear energy from nucleus, geothermal energy, heat energy under the earth, wind energy, that's mean motion of wind or air, sound energy obtained from sound, magnetic energy obtained from magnet, and mechanical energy, that's mean energy obtained from kinetic energy and potential energy. So when work is done, that time stored potential energy initially convert kinetic energy, then it converted into other form of energy. During the formation of other form, some undesired form of energy is dissipated. This energy is known as degradation energy. Consider during the transformation of electrical energy to light energy, a major part of electric energy is lost in the form of heat energy. As for example, when bulb is lighted, that means it is electrical energy converted into light energy, that is desired from heat energy, which is not desired but also produced. This energy is known as degraded energy. That means the energy which is not in the used form but always formed during the formation of energy is known as degraded energy. Now discuss different formula of this section. Potential energy equal to mgh, increase in potential energy equal to mg h2 minus h1, where h2 is greater than h1. Kinetic energy equal to half mv square, increase in kinetic energy equal to half mv square minus u square. In case of spring, potential energy of spring equal to kinetic energy of gain by the object. Loss in kinetic energy when any object strike the ground equal to initial kinetic energy minus final kinetic energy. During this condition, some amount of energy is lost due to heat, which is due to causes the collision of ball with the ground. That's mean during this some amount of energy always lost. These are all about the part B, that is mechanical energy and different form of energy. Now we discuss some numerical. Here we consider 500 liter of water is raised from first floor of a height 4 meter to its third floor, that is 12 meter. Then state whether the potential energy of water will decrease or increase. Mass equal to volume into density. Volume 500 liter, density 1 kg per liter given, therefore mass 500 kg. Increase in potential energy equal to mg into difference in height. M equal to 500, g equal to 10, difference 12 minus 4, that is 4 into 10 to the 4 joule. Increase in potential energy equal to 4 into 10 to the power 4 joule. Here we consider a block of mass 30 kg is pulled up a slope as shown figure with a constant speed by applying a force of 200 Newton parallel to the slope from initial position A to final position B. তাহলে A থেকে B তে অবজেক্টকে তোলা হলো, কত ফোর্স অ্যাপ্লাই করলাম 200 নিউটন, আর লেন্থ কত 3 মিটার, AB 3 মিটার, BC 1.5 মিটার. Here calculate the work done by the force in moving the block A to B. Therefore work done to carry this block A to B find out work done, and also the potential energy gained by the block during this change, and also account the difference in answer part 1 and part 2. So initially work done by the force in moving the block A to B equal to F into AB. Putting the value of F and AB, we get 200 into 3 equal to 600 joule. A potential energy equal to, we know, mgh, where h equal to always the vertical height, that's mean 1.5 meter. M equal to 30, G equal to 10, 1.5, that is 450. So potential energy 450, but work done equal to 600. That's mean 150 joule is lost due to friction of block with this slope. That's why difference in energy is seen. Here we consider another example. A spring is kept compressed by a toy cart of mass 150. On releasing the cart, it moves with a speed of 0.2 meter per second. Calculate the potential energy. So here potential energy stored in the spring changes into kinetic energy of the cart. Therefore potential energy of spring equal to U. Kinetic energy gain equal to half mv square. Putting the value of mv, we get U equal to 3 into 10 to the minus 3 joule. This theory is already discussed in this section. That's mean kinetic energy is potential energy is converted into kinetic energy. Here also we discuss, in case of spring, potential energy of spring equal to kinetic energy gained by the object. This numerical is the application of the before theory. If you have any doubt, you must write in comment section, and if you have any mathematical numerical problem, you must write in comment section. I will give the answer. Thanking you.